Be starting with the types of graphs which are available. So obviously we'll be talking about line plots, bar plots and all those things. So we'll go ahead and discuss the same. So when you expand this and see the types of graphs, following are the basic types of graphs which are chosen based on situation and availability of data. Line plot, dot plot, bar plots, pie chart, box plots and scatter plots, right? So we'll understand these and how to do that in R. So basically talking about a line plot first. So the basic parameters which you will be using for tuning a line chart, right, is P, which stands for the points, L, which stands for lines, O, which is overplotted points and lines, and BC, which is for empty if C joined by line, S, small and capital, so what type of steps you require, stair steps, H, which is like an histogram like vertical lines, and N does not provide any points or lines, right? Now these are all parameters which are used for changing the appearance of a chart or a plot, right? So we'll be actually seeing this in application rather than actually just going through all of this. So let's use it on a test data set and see it for ourselves, right? So what we are going to do is now we're going to create a vector X, and I'm going to say C 1 sequence of 5, right, and Y sequence, and Y is nothing but X itself. So created some data, right, and you're saying par, this partition, PCH is equal to 22, so you're selecting quite a heavy attribute over here, and you're saying red, you're specifying the symbol and the color, and then you are further tuning this. It's saying par MF row. Now this is where you're bifurcating your plotting object into 2 rows and 4 columns. So the 2 specifies the rows and the 4 specifies the columns, right? So you can do this, and then you're saying ops, that is options, is basically equal to C, and say specifying P, comma L, comma O, comma B. What you're trying to basically do is you're trying to run it in an array structure. So you're specifying it as a text, and then you might use it in a loop form, so that you can use all the available options in one code itself, so that you can show all of them together without having to do a lot of manual work, right? So that's it. And now we have to write a for loop, right? So let's do that. For, so you should ideally write it in a code window or in a text form and then run it in one go, but for this case we can try doing it directly over here. So it will separate it with a symbol of plus signs. So I'm just saying delete over here, and so that's how we're going to write it. Heading is equal to paste, and you're saying type, and you're going to put this as a text. Type is equal to, just closing it over here, and then you're saying OPTS, which actually is nothing but this array of string vector, right? So you have specified P, L, O, B, C. These are nothing but parameter values which you have already put over here, and you're using I from 1 to length of opt. So length of opt is 1, 2, 3, 4, 5, 6, 7, 8. So you're trying to iterate this into 8 loops, right? That's what you're trying to do. Intention is to run through various plots in one go. So you're going to plot an X versus a Y, and you're saying type is equal to N, and main is equal to heading, which is already done over here. You can see, okay, we have done one small mistake, that is we have put this as paste instead of paste, so we'll have to rectify that, right? So I guess we should use in the code window only. So I'm just going to copy this from this portion. Okay. Let's go in history. Selecting from here to source. Last part again to source. And I'm just going to change this to paste over here, and coming back over here I'm saying lines is x comma y comma type is equal to opts and I. So again a looping over here, and then I'm just going to close this loop. I'm just going to say select all, and then you can say a run. Just check this, there is still something which is pending. Must have missed on something over here. Okay, this should be as an object and not as a text. First you have to press an escape over here. Just cleaning this off and running this whole sequence again. So you can see in one shot you have created all these charts with different types: P, L, O, B, C, S, small s, capital, and H. So these are the various visualizations which you can see, and just that we have used some looping mechanism so that we don't have to individually plot all these things, right? So you can make use of them whenever required. So let's move ahead. So now we'll go into dot plots. So we'll be constructing some dot plots. So we are going to use a dot chart, a dot chart, right? And this is in base R itself. So I'm using the empty cars data set, and I'm saying mpg, that is miles per gallon, and then I'm using labels is equal to row dot names. So obviously the car name which we could see over there, like whether it's a Ford Mustang or something else or a Peugeot, I'm going to use that data also. Cx is the strength, and it is 0.5 as we are specifying relative to the whole object, and color is equal to blue, which you can change as per your requirement. Main is the title, and it's equal to gas mileage by cars, and the last one is x lab, which you're saying is nothing but miles per gallon. So it's the title of the x-axis, right? And I'm just going to press enter. So this is how the data is. But observe one thing, that you had specified the partition in the beginning, right? So that it should be 2 by 4 partition, right? So that's the reason why this chart has come small, because it has just taken the first partition, right? So if you just say par mf row 2 comma 1, it will again change the whole way in which we can see this chart. Now it's also important to know that a dot plot makes sense relative to the data. You cannot use it for any type of data. You should understand the data, and accordingly you can use those plots. It makes sense when you're using it on a data set which has a dimension which is mentioned on the variable car name or the car type or the brand itself, right? Otherwise you won't be using it, because typically, say for example, in a very huge data set, you won't be putting every customer's data on the y-axis, right? Doesn't make sense. So it's important to know what type of data you're working on and accordingly use it, right? So let's say my cars, right? So we're just extracting something from empty cars, and we are saying order, right? So we are using the ordering functionality, and you're saying empty cars $mpg, right? And saying select all, to just order it, right? And then you can say my cars. So you just prepared this my cars right now so that you can use it later. Dollar cylinder, and you are now converting into a factor, right? So you're converting into a categorical form. So the cylinder, which basically stands as a number, so 4 cylinder, 6 cylinder, 8 cylinder is basically a number, as you can see in the data, but its meaning is different because it is a categorical form. Obviously an 8 cylinder engine is a very powerful engine, and a 4 cylinder engine is not a very powerful engine, right? So you are forcing R to see it as a category rather than see it as a number. That's what we are trying to do. And you're saying my cars dollar CYL. So you're overwriting the numeric form of data into factor form. Okay, it's my cars. Okay, so now it is seen in a factor form, and then you can go ahead and say allocate my cars dollar. You are creating a new column, right? For each car, a car cylinder type, you are assigning a color. So for the cylinder 4, you are assigning a color of red, and for cylinder equal to 8, you are assigning a color is equal to purple, so that you can show the very same data in a different form, right? So now let's do that. So you're saying my colors, my cars dollar color, and you're saying my cars dollar CYL, where the cylinder is equal to 4. There you're saying assign this as a red color. Okay, we just missed, sorry about that. Okay, yeah, similarly I'll just use the same code and just make some small changes. Again, 6 I'm going to put, instead of the red color I'm going to put blue, and this I'm going to say purple instead of the 8, right? So the same graph, if now you use the dot chart as you had used previously, so I'm just going to use the up arrow key and bring the same previous code, right, for the dot chart. So mpg labels is equal to row dot names empty cars, right, and cx, everything else remaining same, but you're adding one more parameter after the 0.5, which is saying groups. Now because you have created some groups, so you can say my cars dollar, and over here you can mention the groups which you want to see, right? So it is basis CYL, that is the cylinder type, right? And furthermore you can say color is blue, and you can make some more additions. xlab is equal to mpg, xlab over here is mpg, so I'm just going to change that, right? And gas mileage by cars remains the same. The color is removed because that's something you're going to extract at real time from there, so you're bringing that to the last one, and that you're specifying over here as take it from the database itself, or the data frame itself. So that is my cars dollar color. This you have specifically created as a new column, right? And now if you check these two, basically same data but expressed in a different form. So you can see over here. Now let me make it easy for us to see this, right, because it's very small. So let me use the partition again, pr mf row is equal to c, and let me say this is a 2 column and 2 row and 1 column, and then I'm just going to do the first dot chart and the second dot chart together, and then you can zoom this and see for yourself. And this makes more sense because now you have these bifurcated on one more dimension of engine type: 4 cylinders, 6 cylinder and 8 cylinder. It's the same data but represented in different form.